Hello, Physics 20 students. This is a quick tutorial on the Unit 2 assignments. So we'll just go through each question, and I'll do a sample question just to help you out a little bit. So the first question talks about a lawnmower handle making an angle of X many degrees with the horizontal. So let's just draw a three-body diagram, or just a diagram. Here's your lawnmower handle. Let's say that this is 40 degrees. Let's say I'm pushing on that lawnmower handle with 500 newtons of force. All right, so you're pushing the lawnmower handle this way, and the lawnmower is moving this way. Good. So let's just draw the lawnmower. So here's what we need. Even though you're pushing the lawnmower handle in this direction, obviously the lawnmower is not moving in that direction. It's moving horizontally. So the only force that is making the lawnmower move is the X component. The Y component is pushing it directly into the ground. And since the ground is pushing directly up at it with an equal and opposite force, it's not going down. Only the X component is making it move. So for this question, all you need to do is find the X component. And we can see that we're just going to use, since we have the adjacent here, and we have the hypotenuse here, we're just going to use cosine. So for my example here, the cosine of 40 degrees equals the adjacent x over 500. Therefore, x equals the cosine of 40 degrees times 500. And that will give you the answer to the question. So for this first question, all you want to do is find out the x component of the force that you're putting on the lawnmower handle. Question 2. Question 2 talks about a curling rock. So let's say that we've got, let's change this to a hockey puck. Let's say you've got a hockey puck sliding along the ice. And let's say that this is a really, really big hockey puck. It's 5 kilograms, 5.0 kilograms. It's sliding along the ice in this direction. And it talks about a force of friction. So this is going to be the applied force. The force of friction is going to go this way, opposite the direction of motion. And for this question, they say they're asking for the coefficient of kinetic friction. So the puck is moving. What's the coefficient of kinetic friction? Well, the formula that you should have learned for kinetic friction, or friction, is this. F, the force of friction, equals mu, that's the coefficient of friction, and all surfaces have a different coefficient of friction. So if you have a high coefficient of friction, it means there's a lot of friction between those two surfaces. For example, the rubber tires on the concrete, your rubber tires of the car on the concrete has a high coefficient of friction so that you're not slipping and sliding around in your car. So that's what mu is, times Fn, and Fn, just a reminder, is the normal force. Okay, so in this question, they give you, let's say that we say that the coefficient of, or let's say that we say that the force of friction is, let's just make up a number, 0, because you're on ice, 0.28. So that's our force of friction. Force of friction is 0.28. The hockey puck is 5 kilograms. And the question is asking you to solve for this one, the coefficient of friction. So we rearrange that formula. The coefficient of friction equals the force of friction divided by the normal force. What is the force of friction? It's given to you in the problem, 0.28. This is the one that I made up. Divided by, now what's the normal force? The normal force is, well, let's redraw this. Here's your hockey puck. The normal force is the force pushing it up. And it's obviously counterbalanced by the force of gravity. Since the puck is not accelerating up or down, then the normal force must equal the force of gravity. So we can really replace this normal force here with the force of gravity. And what is the force of gravity of this puck? Simply the mass times acceleration due to gravity. So this is just going to be m5 times gravity. And the negative is irrelevant. All right, so that's how you get the coefficient of friction in this question for question number 2. Good. Question number 3. Question number 3 is similar to question number 1. You've just got 2 forces pulling on an object, and the question asks what is the total horizontal force of the object. So again, we just make it a different example. So let's say I've got one force pulling this way at 35 degrees with 100 newtons of force, and the other force is pulling, let's do it, is pulling in this direction. Let's call that 45 degrees, and it's pulling with 80 newtons of force. And the question is asking, what is the total horizontal component? So what component is making it go in this general direction? So what we're going to do for that is we are going to do the same thing as question 1. We're going to separate this one into a horizontal and a vertical component, but all we're concerned with is the horizontal. And then we're going to do the same thing for this one here. A horizontal and a vertical components, but all we're concerned with is the horizontal. So solve for these 2 things and add them up. Again, you're going to use the cosine because we have the adjacent, and this is the hypotenuse. 100 is the adjacent, hypotenuse. So it's going to be the cosine of 35 degrees equals x over 100. And that's going to give you an answer. Then you're going to do the same thing for the other one. The cosine of 45 degrees equals x over 80. And that's going to give you an answer. And then what are you going to do with these 2 answers? You're going to just add them together, and that will give you the total horizontal component. Good. Moving along. Actually, I'm going to stop this video and just and then we'll do questions 4 and 5 in a separate video, just so the videos aren't too long.